Do you ever feel the need to do more than you should? Well, now you can by solving system of equations using multi-step inverse matrices rather than a simple substitution. Aim. How do we solve a two-system equations using inverse matrices? First, what is a matrix? A matrix is an array of numbers surrounded by brackets on either side. So we have a matrix down here, but how do you name a matrix? A matrix is always the number of rows, which is 2, times the number of columns, which is 3. So this will be considered a 2 times 3 matrix. Solve the system below via inverse matrices. Okay, so first we have to take all the coefficients and place it into matrix form. So you bring down the 2, and there's a negative 1 in negative y, so you bring down the negative 1, and it will be 4 from the second equation, and then 3. And you multiply that to x and y, and you set it equal to the answer, which is 3 and 21. Next, multiply both sides by the inverse of the matrices that is being multiplied to the variables. But how do you find the inverse of a matrix? First, you swap the position of A and D, so it'll be D and then A. Next, you change the sign of B and C, so it'll be negative B and negative C. Then, divide every single number by the determinant of the original matrix, not the matrix after the inverse. So, how do you find the determinant? The determinant is A times D minus B times C. Now that we know everything that we need, let's get back to the original question. Okay, so first, set it to matrix form. It will be 2, negative 1, 4, 3, x, y equals 3, 21. Second, find the inverse of the matrix that is being multiplied to x and y, which is this one over here, and we have it down here. Okay, so we have to find the inverse. First, we swap 3 and 2, so it'll be 3 and then 2. And then you change the sign of negative 1, which will be 1, and you change the sign of 4, which will be negative 4. Third, divide every number by the determinant of the original matrix. So, as we know before, the determinant will be 2 times 3 minus negative 1 times 4. So 2 times 3 will be 6 minus negative 4. And then you keep change, will be 6 plus positive 4. And the determinant will be 10. So when you divide every single number by the determinant, you get this matrix over here. And then now the fourth step. Now that we have the inverse, we can multiply both sides by the inverse to set x and y alone. Okay, so the original matrix multiplied by the inverse will cancel out, therefore leaving x and y alone. But we still have to multiply this matrix on the right side, which we have down here. So this matrix times the inverse. But now, how do you multiply matrices? First, we have to make sure the number of columns in the first matrix is equal to the number of rows in the second matrix, or else the multiplication wouldn't work. So, the first matrix, we have 2 columns, which is equal to the 2 rows in the second matrix, so the multiplication will work. But how do you multiply? You multiply every single row by the column. So it will be A times E plus B times F. And then the second row will be C times E plus D times F. Going back to the original question, how do you multiply this matrix by this matrix? Okay, so first, based on what we learned, we have to make sure the number of columns in the first matrix is equal to the number of rows in the second matrix. So there's 2 columns in the first matrix, which is equal to the 2 rows in the second matrix. So therefore, multiplication is possible. But how do you multiply? So we learned before that it's going to be rows times the column. So it will be 3 over 10 times 3 plus 1 over 10 times 21 on the first row. And in the second row will be negative 4 over 10 times 3 plus 2 over 10 times 21. So let's do that. So it will be 3 over 10 times 3, which will be 9 over 10, plus 1 over 10 times 21. So it will be 21 over 10. And then the second row is negative 4 over 10 times 3, which will be negative 12 over 10, plus 2 over 10 times 21, which will be 42 over 10. And then now we have to add everything in the matrix. So 9 over 10 plus 21 over 10 will be 30 over 10. And then negative 12 over 10 plus 42 over 10 will be 30 over 10. And then you could simplify, which will be 3 and 3. And remember, it's equal to x and y. Because x is equal to 3 and y is equal to 3. Therefore, x equals to 3 and y equals to 3, which will be the final answer. Just to double check, we can plug it back into the original equations. So 2 times 3 because x is equal to 3 minus 3 because y is also equal to 3 equals 3. So 6 minus 3 equals 3. 6 minus 3 is 3, which is equal to 3. So therefore, it does work. And then now the second equation. 4 times 3 plus 3 times 3. 4 times 3 is 12 plus 3 times 3, which is 9. And this adds to 21, which is equal to 21. Therefore, the second equation also works. So therefore, the answer x equals to 3 and y equals to 3 is correct.